So let's hit play for first. Now this works pretty good for the most part. The only problem that I can actually identify is that if both agents, or if there's two agents, something that's probably going to happen over here, go on the same node, or will try to go through this node and this guy will try to go to this node, when the Pathfinder happens, sometimes they sit, as you will see over here, or like this. Yeah, they basically do not ignore the transition. They will do the movement and this will happen. They will clip through each other. Okay, to fix that, all we have to do is to basically tell that this node is now occupied until the agent has actually reached another node. But it's not something we're going to do on this part for now. Okay, so let's delete the debug log. So now I actually want to add the second story. So we'll have a general idea of how everything like this is going to be working. So let's think. Well, first of all, we know for sure that we're going to need to have this here. And let's say that the second level will be from this. Or, well, basically, yeah, let's maybe delete some of this. Let's copy that and let's raise this. So the thing now is we kind of need to know that this actually creates node positions for us to walk onto, and I think it will make a little bit more sense if we just take one of these and I'm going to move it over here. Okay, and this will be, so we still have our grid lines, but let's make sure they are in the correct position. Something like that. Okay. Now obviously we're not going to need all of that, but let's just move this over here. So let's go under our grid. Let's close all this, we don't need them. And we don't really need all these agents anymore. So let's just keep the two of them. It should be fine. So let's open up our grid manager. And we're going to start visualizing them again. But let's see how we should do this. So, well, the idea should probably be, although this only happens when we request the node, so at start it's not really going to work like that. But, well, okay, let's see. We can do a read node in here, and we're checking for overlap boxes. Okay, and if they overlap something, yeah, okay, so we're just going to create, although I think we already do that. Yeah, we'll do this with this, not with this, with this. So let's see. Let's see where we add the visual positions. We add this when we do a read node. Okay, so here's what my trick is going to be. I'm going to force a read node on everything that is on the second level. After we need the grid, I'm going to go over here and I'm going to say, let's see, we have our grid. So for X, size X, for Y, size Y, and actually let's do it on the entire grid. So Z, all I'm going to say, get node X, Y, Z. Okay, now this will go in here, And what this will give us, in here, it's going to read the node, and if it's walkable, it's going to add a visualization position. If it collides with something, so we'll see, maybe we interrupt, or maybe we collide with our floor on the second floor, we might not even get, you know, any objects over here. But I think we should be fine since this seems to be touching. So let's see. Let's hit play. This will take some time because we do not have any yeah, okay. So, well, this kind of worked, but we don't really get any results over here, and I don't know if that's from... Well, let's raise this above and we'll see. Obviously we have 2 times the size. Yeah, it was the size of the grid. So with this now we have multiple floors, as you can see, and it actually worked great. Obviously we are not checking if you can walk or if you cannot walk over here, so we should be painting also floor tiles. Okay, you know, in Sims you could also paint the floors, and you could also place floors on the second floor and above. So that means we should be doing that either way once we create the level manager. For now, all we have to worry about is to actually make this yeah, we actually want to make this into a walkable position that won't allow us to walk right onto the air. So another way to do this will be to do a raycast here. If we say that there is no collisions for this, we can do a raycast down, and that raycast will start, of course, from, well, the wall position really. Let's add a little bit of an offset. I think that will be fine. We're going to be going down for, we can go at 1, or maybe we can go a little bit higher, maybe 1.5 or something like that. For now I think I'm just going to go with 1. Out hit, and we do want to cast this on all layers. I did something wrong, I think. Raycast. Let's see, raycast hit. Maximum distance is 1. Yeah, I think it might be taking... Oops. Okay, this part means all layers. So, yeah, of course we don't actually want all layers because we do have our players as well into that. So, let's just use the ignore character layer instead. So if you hit something and you're not colliding with a different layer, then you're going to add this as a walkable position. Otherwise, we're going to say on your node, we're going to turn this to false. Okay, simple as that. Minimize it and let's try it. So now we should only get into areas that there's actually some collision happening in below the node. And that didn't do anything. I think that didn't do anything because we're not actually touching the ground, because you have the same distance. So I'm just going to do this. So I'm cutting at half the origin point where we start our raycast, and now we should get all the correct positions. Okay, and we get the positions that are only on top of a floor. So yeah, these guys can actually walk onto an unwalkable node, but I think we handle that from the Pathfinder. That's the issue. So let's go directly into the Pathfinder, and we're going to check if also a node is walkable before we add it. So inside the get neighbor, if search position is not null, we're doing the line cast, but we should also be doing if search position dot is walkable. Otherwise, you don't go there. You don't have to go there. Obviously, it's not a walkable position. Okay, and that should get rid of the unwalkable positions. And he's pretty encased to this, I guess you could say. Although I think, as you can see here, it actually takes the collider of the players into account and makes them unwalkable. But let's try one more thing inside our inside our grid manager. Actually, in the ignore layer, here's a problem. We create the layer before we init the grid, so we should be creating the layer before we do the grid, just so that the grid can actually use the walkable positions correctly. So now we should get the red as a walkable position underneath our player as well, and true enough, we do. And yeah, this guy moved here, but on the callback it got to get another random position. That's why it happened like that, I assume. Okay, so now we're free to go and do the second layer. So what if we wanted to go on a top layer? The idea is that we need to detect that there is a new layer, or there's a difference in the layer we have above, and we need to detect any connection nodes that will allow us to go from one floor to the other. So the idea is we are targeting not the node directly, but the connection point. So let's say we create a lift or something. Okay, I'm going to duplicate that, and I'm going to make this like that. For most purposes, this node is going to behave the same way as an obstacle, okay, because it could be a lift, it could be anything you want, really. So we shall now create a call that gives us this, but we need to detect that this is a connection point for the next floor. On the grid then, let's create a new script which we're going to call connection node, or off mesh link, off transfer position, whatever you want to call that. So this is our connection node. And well, for now, right now, we only need to know the current node this is. And of course, we're going to have to make this public node, current node. Here's one trick that we can do though. We have our grid object, which has some behaviors. Okay, this grid object can be something that moves. We have some values that we're going to, well, basically this. I don't want to be drag and dropping this everywhere. I won't. Well, actually, you know what? Doesn't matter. Let's just do it like this. We can add an interface that will be returning as this, however. Okay, so let's say we want to do well, if we add it as an interface, we're going to have to do it as a function, not as a get set method. Well, okay, for now it doesn't matter. Let's just leave it like this. So, okay, we have a connection node. From the current node, we can tell it that this floor will be connected with the above floor from this connection node. Which means we can go under our game manager, well, basically on our grid manager even. We have our grid, we're going to add a public list because we can have a lot more than one floor, and again another public list for connection node or connection object. Okay, we can say floor connectors. We're going to assume that the floor connectors are incremental, so there's not going to be, well, in real life or in the Sims, if you actually have an elevator, it's going to work like that. Okay, so you could go from one floor 5 floors up, but let's assume now that these are actually stairs, not an elevator. So that means to go to the 3rd floor, I'll have to pass from the 2nd floor, and so on and so on. And yeah, so let's go and do this, which means for the init in the grid we do over here, when we actually create the grid, we can do for size y. Now we're going to be creating a new connection node, a new list, and we're going to add it empty to the floor connectors. Okay. Now when we're going to add the build mode, we're going to incrementally and automatically add new floors and add new connections and new floor connectors. For right now, we're just going to go through, well, we know this is working fine. Well, actually, it's not really going to be that much of a bother. Let's leave this as well. But what I'm actually going to do is, the same way we have snap objects on grid, I'm going to find all the connection nodes. I'm going to do game object, find object of type, connection node. Okay, then for each connection node, see in connection nodes, we can do, well, first of all, we need to know the node they're in. So that will be get current node. And the Y position of this node is going to be the index we're using for the floor connectors. Which means floor connectors node.y dot add the connector. So for that floor, on that list of that floor, we're adding this over there. From the Pathfinder now, we want to find we actually want to find the same way we're doing get node. We want to find a get connector node. So that will be get connector node, and we only want to pass the floor we're in, which means we're going to have to, well, we're actually just going to add this inside our grid manager. We don't have to do it like that. So we're going to say public connector node, connection node, get closest connection node. Now this will be a straight up distance check. Okay, and the reason for that will be, well, to make it easier. I don't want to do a Pathfinder to find the connector node. This isn't really a game that time is an issue or that you have to be really fast with your decisions. So we're just going to find the closest one, and most likely you have what, 2, 3 stars or 5 or whatever. That's still not really a lot. So we have on our integer y, okay, so we have our floor connections, which means we can do for each, actually we want a for loop, not a for each. For I floor connectors y dot count, delete this, then we're going to add a minimum distance, which is going to be the float dot maximum value. Okay, then we're going to have the integer or the result, connection node result. Okay, then for each connection node, of course we actually need to know from where we're getting that, which means we're going to be passing a node as well. So we're going to have float distance vector3 dot distance node dot wall position floor connectors, that's not a float connectors, floor connectors y dot get or current node, yeah, y I dot get current node dot wall position. Okay, we have a nested, two nested floor connections over here. So if this distance is less than the minimum distance, which the first time of course is going to be, then the new minimum distance is now the new distance. Then the result, for now at least, is going to be floor connectors dot y and I. Okay, and so this will get us the closest connection node we have. On the Pathfinder then, get connector node, we're going to have to pass the origin node or the from node, and for now this will just return grid dot get closest connection node on the y and pass the from. And yeah, this will return you, let's say that this is a connection node. So now we're going to have to detect if the target node we are is on a different level, which means whenever we are requesting the Pathfinder in the Pathfinder master, whenever we are doing this, we're going to be offsetting, or we're actually going to create a new callback to pass on the onReach callback. Let's see, and we have the hash path. Okay, and onReach callback. So that will be void onReach callback. Yeah, actually we're going to store the node, stored target node over here, yeah, and we're going to say request or try Pathfind on store target node. Okay, so we're going to do this again. We're going to write this in a bit, which means if start.y is not the same as the target.y, then we need to find the the connection nodes, which means then the target is actually going to be grid yeah, okay, I guess we didn't want this inside the Pathfinder, but it doesn't really matter. So that will be grid manager get closest connection node from start.y and from start. That's it. That's your new target now. And let's see, we want to pass a node. Yeah, this is a target, so we want the connection node. Okay. One problem though. We don't know if this connection node goes up or down. Okay. So we need one more category in here, or identification, which is going to saying is incremental, is going down. I'm just going to write. Keep it simple. So whenever we are actually telling to find the closest connection node, actually, you know what? No, we're not going to do it like that. We have a different way to detect that, and we have a different way of finding this. So we're going to always say that all connection nodes are going upwards. When I want to go from the top floor to the floor below, I'm going to be checking the connection nodes of the below floor and not the floor I'm in. Okay, which means on our Pathfinder master, we now need to know if start.y is less than target.y. So we're going backwards, downwards. And on the else of this, of course, is going to be higher. So let's actually do it like this. So we're going to say we have our connection node. Okay, and with this, it's just going to find you because we're going upwards. We're looking at the same level. Because we want to be going downwards now, we're going to be saying start y minus 1. But at first, we should say if start y dot minus 1 is less than 0, then that means you are at the bottom. So that means the whole path target is invalid. So we are returning and we're calling on reach callback. Okay, just in the technically, because we are automatically assigning the nodes, this will never happen. Okay, so with this, now of course we don't know if we are actually going to be getting a connector. So that means if we are here and connector is null, then it's still an invalid path. So we're also going to have to store a delegate what's going to happen on path reach. Store path reach callback. And here's the problem though. We actually don't know if there's multiple Pathfinder calls, one will override the other. But we're going to fix that one problem at a time. Okay, we don't have to make it that complicated anymore. So we're all going to try with one agent, because a second agent, if it's going to try and pathfind to this, it's going to override what we store here. So, well, actually, that's easy to fix though. If we are passing the agent as well, then we can just store this right on the agent, which is a really good idea, to be honest. But we're going to do this on the next part. For now, I just want to finish with this. So let's say if this is happening and connector is not null, then path, then we're going to store target node. It's going to be stored on the target from the target, and store reach path reach callback will be the on reach callback. Then on reach callback is going to be the try Pathfinder on stored target node, and of course we're going to have to pass a few more things. Let's see the definition for the onReach callback. OnReach on path reach callback, store callback. Yeah, the definition was correct. Store target node. And I think technically we're going to have to store who is the one that is requesting this either way. So let's say store target node will be, oh, we already do that. Our target node now will be the connector dot get current node. Okay, but we do need to store this. We do need to have an access to the grid object. So let's split this in half, and we're going to say in the Pathfinder, at least, we're going to have to pass the big definition. We also want to pass who is requesting the object. So we're just going to call this user or agent, better yet. Okay, so this is going to backtrack to all of this, and it's going to be giving us and saying the agent grid object agent. No, we're passing that. Let's see where we are getting this from. Yeah, from the request path find has path grid object agent. Okay, then inside here where we are requesting the path find grid object is going to be this. Then we're actually going to move everything we have from the Pathfinder master from here. Let's put this here. So we have the grid object above. We want to move this inside the grid object. We're going to turn this into a public void though. Okay, and then we're going to have a public void store Pathfinder data, and we want the callback we had before and the targeted node. So node target. Which means store target node will be target and store path reach callback will be your callback. Okay, so that means try Pathfinder store target node. We're going to basically take this, paste this in here, and we're going to change the store target node to this. We don't have a random node anymore, and we're going to have the store callback for that. Okay. So one more thing that we should do, well, we now should fix the Pathfinder master. We have a few problems now. We don't need this at all anymore, this actually, because we can say on the agent store Pathfinder data, the target, and the onReach callback. And now the onReach callback will be from the agent try the Pathfinder on store target node. Okay, and then we have our target node. And this will basically do a Pathfinder call towards the connection position. However, if we reach there, it doesn't actually mean that we're going to have we are going to move to the top floor, so we should also take care of that. Let's see what happens on the hash path. Actually, you know what? This could have been offsetted inside the agent as it is. So we could be using the different. Yeah, okay, whatever. Let's say hash path request Pathfinder node. I think it will make a lot more sense if we actually do this in here. Yeah, okay. I'm going to do that there. So I'm going to cut all of this, because there's really no need to go and change all of this. We could just drop this inside the grid object, which most likely later we're going to name. And here we are. Yeah, okay. Here we are. So request Pathfinder node. Let's change this. The random node should be first. We need to have our current node.y versus the random node.y. Then again here and here. Then get current node and get current node. Okay, get current node. On reach callback, we actually have the callback right away, so we don't have to do that. Same with this. We should change this now. Get current node, get current node. Or technically, because we are only using one node, the node itself. Okay, this could be done as well. But no, this will be a problem because we're actually checking the indexes. So yeah, let's leave it like this. Should be fine. Then store Pathfinder data, we already have that. We do not have a target, but in this case it's going to be the random node, which I'm actually going to rename to target. And technically we should be passing the node here. Okay, so we should do it like this. So here we're going to be passing the target. On reach callback, we do have the callback above. Then we're changing the callback. Then we are assigning the new callback, and then we are requesting the pathfind with the load path. Here's the thing. Load path, it's going to come down here. And let's see, request Pathfinder node. We do have a callback, and we do want, yeah. So instead of doing this, we're going to say let's comment this out as well. Where were we? Assign a random grid position. So on start, drop that here. Then on hash path or load path here as well. Here's the thing. We're going to assign, well, technically this will have to be on the callback. So here's what I'm going to actually do. I'm going to add a method that is going to say travel up. Okay, whatever, it doesn't really matter. What matters is we're going to do get node, and we're going to say on the grid manager get node, and that node now will be a get current node dot, well, actually let's just store the current as well. Over here I'm using this because the getter will be accessing the get current node and so on and so on. So that will be current X, current Y, current Z. We're going to have the same one. We can clamp it, yeah. Here's the thing. If we're going up, we want the above node. Okay, and here's the trick now. We're just going to teleport there for now. We're going to use animations and stuff later. So that will be get node dot wall position on our transform position. On that travel lamp, I'm going to go on my path on the request. Okay, and before I change the callback, I'm going to say the new callback will be first travel up, and then on that delegate add the try Pathfinder on store target node. So that is going to happen. We're going to teleport on the node above, which automatically makes it so we are on a node above, so we are higher than the level we are in. So that means now the current node and the store target node, we're still going to request a Pathfinder, but we're not going to do it from here now. We're actually going to do a recursive operation with this request Pathfinder node. So if there is even more layers above, more levels, then we're going to call it like this. Perfect. So I think this will work. If we didn't forget something, this should probably work. For right now, because I don't want to mess with so much with the Pathfinder, I just want to see if this is actually going to work, which it should. I'm just going to remove the box collider, and I'm going to add the connection node. I'm just going to move this down though, just so that I know the pivot is on the first floor. And all we have to do now, well, of course we're going to have to close this guy, although technically he shouldn't be a problem now because we moved everything back to the agent. So all we have to do is basically get a random position, a random node on the top floor. So get random node. We're only using X and Z. So for Y we're going to say, well, actually we don't have to say anything. We can just do get node 1. Minimize that, and fingers crossed we're not going to crash Unity basically. So let's save, let's hit play, and let's see the results. Okay, we have a Stack Overflow on grid object 11. Why do we have a Stack Overflow? Why we're calling this so much? Because we're calling this, get node calling that, then back to the game manager, or back to node. Yeah, okay, so here's what we're going to do. On start, inside the assign a random grid position, we're going to attach this, and we're going to put some breakpoints, and let's see it with that. So we are here, we're going to assume this works fine. So we now have a node that belongs on the second layer, although it's not walkable. Okay, so here's what I'm going to do, just so that we have walkable positions. I'm just going to tailor this like that, and we'll see if it actually moves. We're just going to change it later. We're not really checking if there is any walls above us to go anywhere, so that should be fine. So let's hit play. So now any random node we're going to get should be a walkable node, and yeah, Visual Studio kind of froze right now. And the reason it froze was actually because of all the operations. But let's, okay, here we are. We're good to go. So we have our target. Well, on the next one we're going to have our target, and we can see that, what? It still falls. That's not good. Let's see. Yeah, that's not going to be good. It's going to give us all. Yeah, this one will work. So walkable is true, which means, oh yeah, we have the, yeah, we forgot to minimize the grid, so there's a few positions that are off the grid. So request Pathfinder node, let's close that and let's see what's going to happen. So we know that this is going to be on the top floor now. The current node is higher than the target Y. What? Our current node is 0. Oops. Yeah, that's the opposite way. We actually want to do this like that. So we're going up, and this we're going down. Okay. Let's attach this to Unity, however. I'm actually just going to leave this, and we can tell it. Let's see, if we do a random node, we are getting a node that's clamped. Okay, then you're doing all of that. Then you're requesting a Pathfinder. Okay, we can make this slightly faster. So let's give it a shot. When Unity, of course. Unfreezes. Come on. Okay. Let's see. So we are here. And let's see, actually, is the target node? Yeah, okay, so you know what? Let's do it like this. So we're going to say if target dot is walkable, is not walkable, return callback invoke. Okay, minimize that. We forgot to do, well, it's actually moving. Don't know where it is now though. Yeah, okay, so it has reached over here. So that's good. But we need to go on top. So that means we are missing the callback didn't change. So we have the travel lamp. Yeah, I think we don't have this, but we could check if this is actually happening and if the problem is moving it or, well, we'll see. Clear that. Let's hit play. Do we have the breakpoint? We do, okay. Okay, so it's going to go over there and we should get the callback, the travel up, and we do. Then we do current node. We change the wall position, but I'm going to guess if I add a breakpoint here, and click continue, this happens after we reach, which changes the target position. So it basically just overrides our own position, our own transform position to what we just did. That's why this happened. However, we could do a trick now. Later we're going to be doing something entirely different, so it doesn't matter. I'm just going to change the get target position to get current node. Okay. So let's change this slightly and let's move it like this, and let's move this one floor above as well, move it forward, and then I'm going to duplicate this and move this here, so that means this needs to be a little bit downwards like that. Okay, so that means it's first going to go here, it's going to go here, and of course for all that to happen we should be getting a random node that is always incremental and not on the first floor. So get random node. I'm just going to change this to get current node, or this is on the grid manager though. Yeah, okay. So let's pass the Y then. So that will be get current node dot Y plus 1. So we should be going upwards, upwards, and upwards, or whatever. Of course, after we find the node. And that didn't work. We're still on the first floor. So the travel up didn't actually work. Which means well, okay, technically, if we are moving, we should have a call that path is finished. Okay, and we will start as false, and if path is finished, then we're doing this. So all we're going to say here is path is finished equals true. Then inside our travel lamp, or travel lamp, transform.position get current node. No, that's wrong. We want get node wall position. So yeah, previously we had the wrong node targeted, so whatever. And voila, we start traveling up and up. Okay, awesome. Let's see, one more thing that I want to do is, let's try the opposite now. So we'll start on top floor and we're going to go down. And of course, we're going to change the travel up to travel down. For now, we're going to have an animation onto this, so you know, don't worry too much about it. Okay. Then, inside our request to Pathfind, where we're checking for all of this, we're also going to be adding the callback if we're going up and if we're going down. Like this. Okay, then getting the node, let's see, Get current node. Yeah, we're doing that on here. That means we're passing this y, so I'm just going to negate this and we're going to have like that. Awesome. Close that. Okay, we're not even starting then. Let's see why that is. Assign random grid position. Well, we're just going to do breakpoints, to be honest. Let's hit play. So we have our target. Is walkable. Okay, it's on the floor below us. Perfect. Then we're going in. Is walkable. What? Oops. If target is not walkable, I don't know how it worked before, but for whatever reason it kind of did, so whatever. Okay, let's attach this again, and we're here. Then we're telling it, well, actually we just want to be here. Don't really care for that. For the rest, so get current node y is lower than target y, which is false, of course, which means we're going here, which means the current node we have for that, which means we're going to do a travel down. We're going to get the closest connector. And let's see, I'm actually curious. It does have a connector. It's going to start the Pathfinder and then the rest. So that means if we click continue, why are you even coming then back again? What? Yeah, for whatever reason we're doing this again. So there's a bit of a recursive operation happening. There wasn't really any reason that we should be going in here. If not target is walkable, invoke it, invoke the callback. Actually, you know what? Let's remove this. I think it's kind of messy. It could be from that. Get closest connection. Get current node. Okay. We want to be going down. Callback invoke. I do want to know if this is happening though. Yeah, that's still not happening. I don't get it. Let's attach this and let's see where do we fail. Well, the place that this could happen could be this. Could be inside the load path, returning it back. Well, let's put a breakpoint inside here as well. So this does indeed happen, but that doesn't matter. Let's see how many floor connectors are 3. Okay. Oh no, we don't care about that. We want about this connector. Floor connectors 3, and we are on the 3rd floor, which is this. which has capacity count is 0. I think we should be at least on this one. Okay. We should be looking at this one, which true enough you do have that, and it is the cube 4. So that's probably not inside this one. Let's do this here. Let's click a continue. As you can see, we do indeed come here, but we add try Pathfinder restore target node, then we add the target. Let's go on the load path and put a breakpoint here, and then continue, and then you see that we are coming in here, so that means you cannot find you cannot find a path because there is no path to go there, because we are going downwards. That's why. So that means we basically just have to do, before we do the travel down, we actually want to aim the target, the node above, so the target onto this. Okay, so let's see how we can do this. We need to know the connector. We need to know if we're going up or down. So bool up. Well, you know what? Here's one way to do this. And that will be this, and that will be although that's not ideal either, to be honest, because we also need a bool. So we're going to say bool is going down, or is going, is going down, or let's say is going up, equals this, then is going up, is doing that. Okay, so going up, it will give you this, going down, it will give you this. Okay, perfect. Then we want to have connector travel up. Okay, so if it's going up, the callback will be travel up. Okay, and this needs to happen here if there is no connector before we do all of that. It's going up, callback, or actually we could just not do anything over here and it will go and try the second phase. So, but if you are traveling down, your target now on going up should be the connector node. On going down should be get node from grid manager, connector get connector node, connector get current node, X. Well, technically let's just save the node so we don't access it all the time, and X n dot Y +1 n dot Z. Okay, we want the above node of our path. Save that, and now it should be working fine because we have access to the target node. Okay, voila, that's actually perfect. That's exactly what we need. And once on the base floor, it just assigns it randomly. So I think we're good for this part, for this video. We have now up and down movement through different floors, which is of course fine, and it's of course great, and it's exactly what we needed. So that's it for this part. As always, you know what to do. Like, subscribe, and if you like to see more stuff like this, more videos, more series, more of everything, then of course consider supporting me on Patreon so we can keep making all of these nice and beautiful things we're making. I'll see you next time.